My name is Andy Kuszak. I live in Northwest Arkansas. Um, I have been in and around construction my whole life and part of some type of trade almost my entire life. There's a 4-year period where I tried to work in an office and that just did not go well. And so I went from residential construction for about 10 years and then went into commercial construction, was on a traveling construction crew. We built casinos and hotels in universities across the United States. And then I had some rental properties. And in that process of buying and selling rental properties, I became aware of the home inspection industry and then decided that it was a really good fit for me. So I've been in business now about 9 years, and it's been gangbusters. A year ago, I decided about 5 years ago, we started to look at what it would take to start a specialty trade school. Wasn't really anything of that type in my area. So, in that whole process, it's taken about 5 years. We finally reached out to InterNACHI, became partner school with them, reached out to my local community college, working with them and using their facilities. And we're just starting to get up and going on doing Arkansas continuing education and initial licensing and doing webinars for InterNACHI. So I was asked to do this deck class. And, we have a lot of we have a lot of experience on decks here in Northwest Arkansas. Most built wrong, at least some aspect of it, and so I'm even putting this class together, and I was still learning stuff. So here we go. So see if I can get this whiteboard to work. Here we go. All right, let's start out here. So, what you need to inspect a deck. The ideal tools you're going to be using are flashlights, measuring tapes, ladders, level, plumb bob, probing tool, hammer. We got all this stuff here. Probing tools, super important. Tape measures. Because a lot of the stuff that we're going to be going over are how to identify later in the slides is how to identify spacing and how far away spacing should be based on the length of the board and so on and so forth. So all that stuff is good. Other stuff that you might need are moisture meters, magnets. Magnets are going to be used to check if your fasteners are metal, are steel or not. Making sure that you have the correct fasteners in there, and then a calculator. InterNACHI estimates that 45 million existing decks, only 40% are completely safe. I would say that is completely accurate. I still see new construction decks built wrong all the time, especially when it comes to fasteners and flashing. About 90% of deck collapses occurred as a result of the separation of the house and the deck ledger, allowing the deck to swing away from the house. It is very rare for a deck floor joist to break mid-span. And then the Consumer Product Safety Commission estimates that more than 6,000 people are injured each year in incidents involving the structural failure or collapse of a deck or a porch. When you inspect a deck, we always recommend inspecting from the bottom first. That's because you want to make sure that that deck is going to be safe for you to walk on. So you want to inspect the deck in much of the same process as deck construction. Inspectors should start at the bottom. If a deck is deemed unsafe from underneath, the inspector should not walk onto the deck. The inspector should stop and report any safety issues. Image above depicts a typical deck load distribution. People tend to gather near the railings of the deck, and so more load is likely carried by the posts. And you'll see later in the slides how the code for the deck railing support posts has changed, specifically because of this fact where people are more likely to hang out on the railing edge. The IRC provides design tables for decks up to 10 PSF, pounds per square foot dead load, and 40 PSF live load. Most decks over here. Most decks are designed and built for loads of 40 to 60 pounds per square foot. Excuse me, let me silence this. Oh my gosh. There we go. The IRC R301.2 includes snow loads of 50, 60, and 70 PSF. A 40 PSF live load is equivalent to a 200-pound person standing in every 2.5 feet by 2 foot area of the deck. That's a lot of people standing near each other on a deck. So might seem a little overkill, except if you decide to have a massive party on that deck, or you decide to start putting other structures on the deck. Stairways also must support this load, but in addition must support a concentrated load. So that would lead you to believe that the deck stairs are probably going to be a lot more important to make sure that they are structurally sound than percentage-wise than the rest of the deck. Like I just stated, hot tubs require framing that can support more than 100 pounds per square foot. A lot of times, people have the greatest intentions. They want to elevate their living standards. They want to do all this stuff, and they make a lot of assumptions as far as deck structure is concerned. But yeah, anytime you see any type of structure on a deck, especially one that's going to hold water, you want to make sure that you are especially focused on the structure underneath that deck. Engineered or alternative designs for supporting a hot tub may be necessary, but may be handled with an over design in the joist, beam sizing, spacing, or spans. Footings and posts. Exterior deck footings should be installed at least 12 inches below undisturbed ground surface. Required footing depths varied based on local building codes. The depth is normally below the frost line, or 12 inches where frost lines are not applicable. A lot of times around here, you're going to see, the precast concrete supports. Those sitting on top of the ground do not meet the footing standards. The 7-foot rule: the best pressure-treated wood for ground contact within 6 inches is wood classified as UC4A or UC4B. This is your typical pressure-treated wood. I went and got, and I know you're not going to be able to see this, but this is the end tag of a pressure-treated piece of lumber that we have back here. It's the 2x10. And the only way to know that this was that this is ground contact rated is by the end tag, which a lot of us are not going to see this end tag unless it's a new construction and they just leave it on. And it actually says on the end tag UC4A. Well, yeah, UC4A is on this end tag. But that UC4A is not stamped on this. The only stamp that you see on here is the SPIB, means this is Southern Pine. Appearance grade is the number 2 prime. Over here, the KD means kiln dried at 19% moisture. And that just means that this piece of wood was dried down to 19% moisture. That whenever anything is pre-dried or kiln dried, that is intended to keep the board from warping and twisting. So if you have a piece of green wood that was not kiln dried, then you're more likely to have warping and twisting in that board. So that's what that means. HT is heat treated. So this little area of this stamp, this is where you would see pressure treated, PT for pressure treated. This is HT for heat treated. And then you have the mill number, which is where it was where it was manufactured, where it's manufactured at. It's 146, and I believe this is somewhere in Oregon. Other than that, trying to identify if you have ground contact treated wood, you're looking for the green or blue hue in the wood. Again, if you have an older deck, it might be a little hard to tell, if it is, but you got to just try and do your best. If you were able to, compare a non-treated piece of wood to a treated piece of wood, you should be able to see the difference, but you might not have that capability in the field. You just try to do your best. The illustration below depicts the 7-foot rule. On steep properties, the slope of the ground around the footing could affect the footing stability. The 7-foot rule states that there should be at least 7 feet between the bottom of the footing and daylight. So yeah, basically, obviously, if this is going to be any type of structure is going to be built on a hill with a slope, just that tape measure and make your measurement and see what you come up with. Anything below that, just pay special attention and make sure that you're using your awl or a thin screwdriver, poking in around where it's in contact with the dirt, seeing how deteriorated that wood is. Ideally, you want that wood to be above grade, where you have either the concrete coming above that grade or something coming above that grade. Even though it is rated for ground contact, best practice is that that wood is not in contact with the soil. Obviously, it's okay that it is, but best practice would be that it's above grade, because anytime any wood is below grade, it's going to deteriorate than the wood that's above grade. So just keep that in mind when you're using your inspection tools. Footings. The image depicts a post base that is not attached to its footing. Posts should be connected to their footing so that the posts don't lift or slip off. This is a good picture of that precast footing. But again, in this instance, you would really want either a concrete footer underneath this or a rock base, that goes down 12 inches below the level or below grade, and then make sure that you have some type of connection between the wood post and the concrete. I'm not paying attention here to your questions. Next. The image to the right depicts a proper post-to-footing connection. Posts should be connected to their footings so that the posts don't lift or slip off their footings. So and you might see this a lot too, is that maybe the calculations that the contractors did during construction were not really perfect, and so you might see where the metal connector plate is off to the side or even hanging off of the footing. If you read the Simpson Strong Tie installation instructions for this connection, all of the metal has to be completely bearing on the concrete. Otherwise, it would be something that I would call out. You put all of that stress and that load on the edge of that, you're very likely going to crack that base, and just going to have settlement problems. Those pyramid-looking bases aren't even rated to be above ground, though, right? If you have no, they're not on their own. I have seen them to where you dig out, you dig out the earth, you put, 3 inches of rock down, and then you could potentially put that precast concrete on there, but you are, that's, so I'm getting a little sideways here. So I've seen that in crawl spaces, but being outside, if more than likely that the earth around the that hole that you dug for the rock is going to fill in over time. So again, yeah, you're probably it's not ideal in any situation. You really need a proper footing, at least 12 inches below grade, in order to meet the standards. Yeah. So Is this acceptable? It is not acceptable. So the rule, let's see. I had my note. Where did it go? That's what it is. So anytime you're pouring a footing like this, the base, the support base, the concrete support base needs to be 3 times the size of the post. So if you're looking at a 4x4, then you need a 12-inch. Then you need a 12-inch footing base. And then you just need to go up from there. So this we would not consider acceptable. More than likely, this is going to crack. As the post and the footing ages. And wrong. So this is a little extreme, but another good reason why you might want to carry a plumb bob with you is, checking to see how plumb your deck and support posts are, making sure that everything is in line, everything is properly supported. The rule of thumb is 1 inch out of plumb and 8-foot height is considered potentially unstable. So with plumb bob, you can be able to check that. You can, if you have the right calculations, or you're carrying a calculator with you, or your phone, then you can do the calculations if you have a level with you, and then do your measurements, your calculations with your level. Non-typical columns may be functional. They need to be evaluated on an individual basis. All the rules apply. Plumb, secured at the top and the bottom, and a continuous load path. So I think we all probably see all the time where methods and materials do not meet standards. And for whatever reason, it could be working. And there could be no evidence of defect. If this has been, this is a rough example, obviously, but if this has been in this configuration for 40 years and there is no evidence of premature deterioration, then I would just, probably recommend monitor, continual evaluation. This is extreme. I wouldn't do that on this one, but this is a little much. But the premise is still there. There's lots of different ways to do construction, and if you over-engineer something, it might not meet standard, but it might function. So I would just do a monitor and recommend continual evaluation and go from there. The IRC did not say much about post sizing, but tall 4x4 posts twist under load, and 4x4 posts, even when treated, decay below grade too quickly. In all but the lowest of decks, deck posts should be at least 6x6 and no higher than 12 feet. 14 feet is acceptable if cross bracing is used. The American Wood Council says that 6x6 posts are the minimum recommended size, and maximum height is 14 feet, even if 8x8 posts are substituted. Now, there is a good, the American Wood Council has a great document out there called the DCA 6 standard. It's definitely very generalized. It's not, and it's generalized for the entire state. So your state might be different, your local AHJ might be different, but it is a really good document to read through to get an idea of, general deck standards, general deck construction. And it really takes everything from, it takes a lot of items from the IRC, it takes a lot of standards from the American Wood Council, and it puts it all in a very easy to read, comprehensive document that can really help your understanding in deck standard construction. Definitely can't hold contractors to it, but it is really good for your information to keep in the top of the mind as far as heights, spans, distances, wood types. Wood decay. Most common form of decay is wood rot from fungi growth in the wood. Fungi breaks down wood and weakens it, and it can lead to catastrophic failure. Inspectors should probe or pick suspected areas for soundness. This is probably one of the biggest things that you're going to be inspecting for when you're looking at a deck. You know, your inspection awl is going to be your best friend. And you know, you might, and you'll see a couple pictures here later. The deck could look great. It might be painted and it looks really sound and good, or it could not be painted, but the face of the wood has very little defect in it. But once you start stabbing with your awl, you'll, I mean, amazingly more times than I would care to count that awl will just go right through, and it's very shocking when you don't expect it to. You know, it looks sound, it looks like it's structurally good, not a whole lot of other visual defects. So one of the greatest things you can do is just probe as much of that, especially the ledger board, your post below grade, and then even your, you know, well, you'll see here in a second, once you get down to where you start to see some of this fungi growth, you know, I think the deck product that is, it might not be this product, but I think it's called like Redeck or Deck Over or something like that, but where it puts a super thick layer of material over the deck to help hide a lot of the deterioration of the wood splitting, cracking, and all that kind of stuff. So, you know, if this, a lot of times people will put that covering over to kind of cover up some of the rot, all that, you know, especially when selling the home, they want to, you know, make it as look as good as they can. So here we go. So this is a good picture. This is kind of what I was talking about before. You can see a little bit of the warping where the deck is starting to, the deck face was starting to separate there. Even before the picture was taken where he shoved his screwdriver through there. But, you know, the connector is not sunken in too bad. You do have a popped nail over here. But all in all, I mean, you probably wouldn't expect that screwdriver to penetrate as deep as it did there. So pay extra special care to, you know, probing the structural members of the deck. And again, I think a lot of this, coming back to here, to this picture, there's no flashing. Now, I don't know what's above this, but if this is rotting out, more than likely you have water penetration coming down from the top here. And without that flashing, it's just soaking right into that wood. And this is the beginning. You know, when you start to see the white fungi growth, this is the beginning of deck rot. You see this a lot, you know, especially where, you know, you have your beams. And I think if you have a deck contractor that's really taking, you know, really conscious of their deck construction, what they're doing now is they're putting self-adhering or self-healing, self-adhering like ice and water shield or flashing tape over the top of these joists, primarily to stop this type of deterioration. Because that water, when it rains, is being held between the deck floor and that beam or that joist, and it's not really given enough time to evaporate. If you have a lot of tree cover that is, you know, covering this deck that's not getting direct sun, then that water is staying in between that joint longer, and it's just slowly over time it's causing more and more deterioration. So yeah, pay special attention to where the deck boards, the floorboards cover over a joist or cover over a beam. Probe those locations, and obviously you want to notate those, put those in your report as needing repair, needing maintenance. And then you're going to get further down in here where you're going to start to see report early stages of wood rot, where you start to see that growth. But this is starting to get more advanced into that wood rot. You know, the rot starting to travel down, further down, and especially on this one, you know, you don't have a separation. There's no separation between your deck floorboards, and so again, you're getting that lack of air movement. Um, you're getting that lack of sun exposure, and all of that moisture is just being held between the floorboards and that deck or that deck joist. Just continue to rot. This is where you're starting to see the advanced mold or the fungi growth. It's starting to get thicker, travel downward. Definitely deteriorating. Down
Hey, Andy, I think we have an actual question this time.
here. Yeah.
Landon asks, in probing and poking holes, do I need to be concerned about homeowners alleging damage to the deck and hand of an inspector?
No, I mean, I wouldn't go crazy for sure. I wouldn't go and start, you know, just jamming holes in everywhere because, but you know, I would representative amount. You know, we use that term a lot in this industry, representative amount. So you know, maybe if you find you know, one rotten area on the edge, you know, go 3 or 4 spans down, probe again. You know, you don't have to, you don't have to waller the hole out, and you don't have to put a ton of pressure. You don't really have to stick, you know, the thing all the way in. If you just give it a little tap, see how the wood reacts. You know, if it goes in at all, that would be a good picture, and then go from there. You know, and then I wouldn't just do one area. You want to see how extensive it is. So, but you don't want to go crazy either. I would say, you know, use your judgment. But I wouldn't be too worried um, about the homeowner being mad about it because the lack of structure is already there, and so I would turn it on him and say, hey, you know, we found this is kind of scary. Or advanced. You know, I don't know if you want to use scary or not, but this is kind of some advanced deterioration, especially if it has to do with the ledger board. Say, you know, if it's as extreme as that picture was, and it's that bad, you know, every 3 or 4 bays all the way down. I This is probably a safety issue for me, and I would recommend you know, this is something I would tell the homeowner because you know if they you know, if your inspection falls through or the job falls through for whatever reason or the purchase falls through, and then they decide to have a party on that deck, you know, until the next buyer puts an offer in, and then that deck falls off the house. You know, I don't know if you would necessarily be held liable, but if you were to warn the customer that you know maybe that ledger board is not the most structurally sound, you might want to have that looked at because you know if you happen to have a family gathering or whoever over, um, you know you want to save you want to save somebody from you know heartache and hurt. So in this instance, if this damage were continuous along that ledger board, I would tell the home. And so if they do get mad about something like that, you know, there's only so much you can do. I think people, um, you know, people's emotions are heightened during during an inspection process. There's a lot of emotion that goes into their home. If they were super proud of it, they're the ones that put this deck up, and you're coming in and you know saying that there's a lot of stuff wrong with it. Um, you know, that's just something that comes along with the industry. I would much rather make sure everybody's safe than worry about them being mad that you poked a hole in a piece of wood that is already obviously deteriorated to the point of structural integrity is in question. Here's another good one. Again, your probe tool is your best friend when it comes to decks, for sure, and the hammer, hammer too. We're going to get to that in a minute, but you know, hitting your bolt heads or your lag screw heads with the hammer, also super important to make sure that you have positive connection with that ledger to the house. We'll get those here in a few minutes. Again, this is just advanced deck deterioration, looking from the deck floor down, looking from on top of the deck down. Very common. So, and I think we've seen this, and you might be familiar with this anyway, but very, very common that, you know, everybody paints their deck, but, you know, they don't paint the edges. So a lot of times that, when you don't paint the edges, water is still going to soak in from the unprotected edges, and it's going to rot from the edge into the board. So, you know, pay special attention to the edges. Same thing goes with any wood, really, on the exteriors. You want to pay special attention to the edges of the boards, both on the sides and on the end cuts, you know, just to make sure, you know, see what kind of rot, see what kind of deterioration is there, and then to recommend to your buyer or your client that, you know, you need to pay special attention to these areas. If they start to rot, like here in this picture, you know, this picture over here, this looks like it's on like the end joist. This one looks like it's midspan, you know, so you know, the deck joist that's right below this is probably rotting, along with the deck floor board here. So yeah, definitely pay special attention to all those areas. Again, another reason to put flashing tape or some type of self-healing membrane between the joists and the deck boards, and making sure you have good spacing between your deck boards, so that, you know, debris does not build up in between the joints. Water can easily drain from those joints, and you know, try and get as much sun to those areas as possible. But you know, everybody loves having a house in the woods, but you know, the homeowner needs to be aware that anytime you have a house in the woods and you don't get that direct sun contact, you don't have, you know, constantly blowing wind, all that kind of stuff that helps to evaporate that moisture out. You need to pay special attention. You're probably going to have to do more maintenance on a deck like that than if it were, you know, out in the sun, with no tree cover. You know, you'll get more UV deterioration, but the moisture deterioration is what really starts to cause you structural integrity issues. This is just more fungi growth growing on the bottom of the joist there. You can kind of see streaks of it all the way through. Looks like you do have a little bit of light coming through. I mean, obviously, I think that's probably water stains in the back, maybe, but that does show that you do probably have some good spacing in between there. But could also, this might be tree covered, so you're not getting a lot of sun contact type of stuff there. And then you get the advanced growth. So, you know, mushrooms growing directly out of the midspan of a board. You know, that's it's a clear sign that you have some issues. But not uncommon. I mean, all of this stuff I see. I mean, I would say any deck that's older than probably 10 or 15 years, you're going to see a lot of this stuff. It's just the nature of wood on the exterior. But that doesn't necessarily mean that you know, you can let it go. It is our job to make the buyer aware of these things, and to let them know, you know, what the maintenance that goes along with having a deck on the exterior. Look at these questions here. So, Roberto, your question, where would the flashing have to be exactly in this picture and what types? I think you were probably referring back to our good picture of that picture there. So you're looking galvanized metal, galvanized flashing. That comes over that ledger board, and there's more pictures of this later in the slides. But yeah, it should definitely come. Well, it's hard to explain in this picture, but we'll get to it here in a few slides. Let me see here. Anybody else? Sometimes tapping with the back of the screwdriver can provide enough confirmation of decay. I agree with that. Structurally sound. James, you're right. We shouldn't say structurally sound. I mean, talking inspector to inspector. That is how I want to portray that stuff to you. But yes, when talking to a client, we don't want to talk about engineer type comments. We don't want a homeowner to think that we're an engineer in any way unless you actually are. But inspector to inspector, just trying to get the point across as far as talking about structural soundness, that type of stuff. Also on flashing, Andrew was mentioning a newer standard for membrane type flashing on top of the beach floor joists. Contact with you. Yes, thank you, Kevin. All right, let's keep going. All right, fungi. So I did want to something that talking about fungi real quick, and this kind of goes along with house structure too. Is that dry rot is a characteristics of fungi. So when we talk about dry rot, and a lot of the stuff that we're seeing on decks is dry rot, or can be dry rot, and that dry rot occurs when fungi, certain type of fungi gets wet, and then it dries out, gets wet, and then it dries out, gets wet, dries out. And that's a lot of times where you'll see where the face of the wood still looks like it's good. It still looks intact. It might be discolored, but you don't see, it's not falling apart on its own until it gets way advanced. So just keep that in mind as far as dry rot is concerned. Is you can wood can always not always wood can look sound, but that's why the probing is so important. And dry rot is part of it, along with all these other types of fungi. And there's hundreds of different types of genuses, and they all kind of do the same thing. They're all feeding, and they're all feeding on the wood fibers in the and so that's a lot of the reason why the face of the wood can still look structurally sound, is that especially if it's been painted, because the dry rot just its little tentacles just travel through the interior of the wood and is eating as it goes, but obviously it needs moisture to eat, so or to help break down the wood fibers, and it just keeps crawling along on the inside. And so, pay special attention to decks that have been painted, because the face of that might look good, but but the fungi might be traveling back behind that paint and deteriorating the structure of the wood. Lichen and fungi evidence. So yeah, the green lichen, that's just another indicator to pay special attention to. That's lichen and algae, that that area of the wood, the underside of a deck never gets sun. It's just the nature of the beast. And so it's really easy for, especially if it's in a very dusty area, that dust will get into the air, it'll settle on the bottom side of the deck. Other organisms, other fungi, mushrooms, algae, all that stuff then settles on the deck, and then it starts to, even if the wood is pressure treated, it starts to eat, the organic material that is just naturally on the wood, and then it slowly starts to work its way into the wood, and then that ongoing process over time will just start to deteriorate. And that is again why clearances are so important. The underside of decks don't get a lot of sun, so you want to get as much airflow into those areas as possible. And the lower the deck is to the ground, the less airflow that is allowed to try and evaporate the moisture that's away. So you want to pay special attention to the minimum clearances. This image depicts best practice, but in the real world, there are exceptions practically in the dirt. Obviously, I think we've probably all seen that. And we see it all the time. I mean, people build decks directly on the ground all the time. I mean, nearly or almost practically impossible to be able to inspect those decks from underneath. I mean, you can give it your best shot. Obviously, you always want to do your due diligence. Find the gaps that you can, shine your flashlights in every angle, in every hole. Try your best to see as much of that deck as humanly possible, especially when it's super close to the ground. So you're looking at 18-inch minimum to the bottom of the joist and 12-inch minimum to the bottom of the girder, or the bottom of the beam. Continuous load paths. We have a hard time with this here in Northwest Arkansas. Everybody still wants to use through bolts that are, face connected, with no notches, no additional supports. I think more and more contractors are getting better at this, but I still find new construction decks all the time. And your AHJs, our AHJs, our local code officials around here don't inspect anything deck concerning. Nothing ever. So it falls on us as inspectors to call this stuff out, which can be very hard. Because obviously, I think we've all heard it's the code, or the code inspector signed off on it, or whatever. So in these instances, I would just say, hey, if they do come back and they say, oh, the code inspector signed off on it, or this is to code, or whatever, say that's not my purpose. My purpose is to point out potential safety issues. And this, in my opinion, is a potential safety issue. We see a lot where this connection over here on the picture on the left, the diagram on the left, when they drill this hole, this is a great place for water to get in back behind the bolt and the washer, and then it's going to start to rot out that hole. And so that's exactly why this is no longer recommended. So probe this with your awl. Make sure you're probing around, all of your through bolts, through all of your lag or your lag screws, your screws, your lag bolts, making sure that it is still in good shape. And then if they don't, if it is not notched into this support, then I always recommend adding either additional like strong tie hardware, metal hardware, or additional blocking down below here, just something else to help keep that up. Because once this rots out, yes, I do recommend a sealer on top of the post to girder connection. Any horizontal location on wood should have some type of protection. What type of sealer? So what type of sealer is the question you would recommend? So any that like ice and water type stuff, or the zip tape, flexible flashing. It's the previous prior to this one. Can't go back. Back for a few seconds. Yeah, hold on a second, Sam. And tell me exactly what slide you want to go back to. But as far as the sealer goes, yes, you want some type of ice and water shield is a good one, or the zip tape flashing is a good one. Any type of self-healing what do I want to say, flexible type flashing is what I would recommend on any horizontal surface, any horizontal wood surface. Go back to this slide prior to this one. So you missed, oh, so you're looking for the minimum distances, the 18-inch to the bottom. This is also the same. These minimum distances are also the same distances for your house structure. So you want 12 inches of minimum clearance to your girders and your beams for your house, and for 18-inch minimum for your joist. So the deck structural clearances and your house structural clearances. All right. All right. Yeah. So now talking about notching in. So if you do have a notch, okay, so the IRC's recommended minimum notching is on a 6x6 post. You're probably going to see 4x4 posts notched out there, but that does not leave very much. I mean, it leaves like a sliver of on that 4x4 post, especially if you're going to use a double beam, you know, a double laminated beam. So, you know, so again, I guess really it just comes down to is make sure you have 1/2-inch through bolts with washers on a ledge cut into a post. You know, there is, I had to look this up a while, you know, a couple months back, but you can have 4x4 posts where this, at least if it's resting, if the beams are resting on the post, that is common. You'll see that a whole lot. Not technically wrong, not standard, not ideal. But where the 6x6 really comes into becomes a factor is when your 6x6 post is extending up into the guardrail, and that's where you run into the requirement of having a 6x6 post if you're going to notch it for a guardrail, and we'll get to that in these later slides. Here are, so these are your 1/2-inch. These are your 1/2-inch through bolts, washers on both sides, on both the hex head and on the nut side. Yeah, you want to make sure it extends all the way through. And I'm talking about the ledger. Well, yeah, talking about the ledger. So these are 1/2-inch lag screws for your. Don't allow any notching in post. That's super interesting. Wayne Turner or Tanner says that our local building inspectors in Canada don't allow any notching in post. Okay. Huh. I'd be curious. I would like to see. I would like to see their code book as far as how they expect connections to be. Roger, this is your license to be. Yeah, galvanized, correct. Yeah. So, oh yes, and these are all galvanized. So, kind of going back to, I think we're going to get to this later, but galvanized, you really have to have galvanized or some type of coated connector when you're going to be connecting to a some type of treated wood, because this treated wood will start to deteriorate non-galvanized or non-exterior coated connectors. All right, let's use stainless. Stainless. So I'm gonna have to look. I think stainless is. Well, here we'll get to that here. Let's keep going. Oh yeah, we were talking about continuous load path. So continuous load path. Again, so this is not a continuous load path, and for this support, so this is the support post. So we're missing continuous load path down here. and the anchors are countersunk into the wood, which is not acceptable. So you can't have countersunk. It has, and you have to have additional supports that come down to this post. So whether that be, strong tie materials, some type of metal connector, some type of additional support post. Can you notch in the middle of the post versus the side? There. Hold on, let me see here. Are the SST post caps sufficient for post to be in connection? Since type post caps. Post caps. Post to be in connection. Are you talking about like the L brackets? Post caps. I'd have to see a picture of the post caps to know exactly what you're talking about, Felix. I will look that up and we'll get back to you on that one. Is there a thread protrusion requirement on the bolt? No, as long the nut has to be completely seated on the bolt, but that is all. It doesn't have to. Now, if you are connecting a screw, and this is mainly on a ledger board, but the screw has to completely penetrate through the board. So you have to be able to see the tip of the screw whenever you're going to use this for your ledger connection. And that is if it's going, through. This is obviously too short, but if you were to look at this inside of a crawl space where the ledger board attaches to the house structure, you should be able to see the tip of the screw coming out the other end. And then as far as your bolts are concerned, as long as the nut is completely seated on the threads, you should be good there. Is there a thread protrusion requirement? Okay, can you notch in the middle of the post versus the side of the post? So we are going to go through, yes, you can notch in the middle of the post. Well, in the middle, like through the post, Brian, or no, the top. Notch. The screw tip, yeah. Thank you, Brian. Agreed. Notch in the middle of the post versus the side. Top. So if you're talking about notch in the middle of the post, you can notch in the middle of the post. I get the last slide where it shows the notch on the side. Yes, this is completely acceptable. Okay. I get this last slide where it shows the notch on the side. Okay, I'm good. Let me go back to the question. All right. All right. All right, so this is just showing continuous load path of the beam to the post. This is good. And ideally, we do not now. Okay, butt joints typically must be bearing on the post, although they can be specifically engineered to be between bearing posts. A lot of this is going to factor in, like it says in here, it's got to be engineered. So if it is engineered where the posts, the force coming down on the butt joint, that force has to be able to be transitioned to the support post. So if they're close together, you're probably fine. If they're super far apart, they're not going to be fine. Again, but it has to be engineered that way. So if you see it where it doesn't look like it's been engineered, it doesn't look like it was, it looks like it was probably built on site, or there was no, I don't want to say this. If it doesn't look professional and you feel like if there can be any, if the load path feels, if you feel like the load path can be affected by the by it being over the top of the joint, then I would definitely call that out. I mean, you should ideally you should always have a support underneath a joint, and if there's not a support underneath there, you just need to pay very extra special attention to where your support posts are. You know, when you walk on that area, does it feel, is there a bow in it? Can you see a bow when you look down lengthwise? You know, you know, there's going to be a lot of factors, a lot of things that should come up if it doesn't feel like it's structurally sound or there's any flex in it. You know, you just need to use your best judgment and for those instances, but you should always have some type of support underneath the joint. Yeah, they're probably Simpson's Strong Tie. They make products for just about every situation. Um, Now, what they'll in that situation, they're probably going to have a tie that's going to go from this post all the way to this post in order to for them to carry their liability and say that it will be structurally sound. And a lot of times in those instances, uh, it would just be better to build it with a support post underneath the butt joint instead of having a strapping that goes all the way across. It's probably going to have to be on both sides. So, all right. Let's see. How far are we at? So we're right at an hour. Do you guys want to take a break or you want to keep going? Keep going. All right. We'll do some more homework on that. Thanks. All right. Thanks, Wayne. All right. Let's do this. All right. The image above depicts notches in a supporting beam. Notches must be less than. Oh, what's up?
Sorry, before you start going, there was a question. Wayne asked, maybe the notching is prohibited. Comment is meant for railing post only. Oh, never mind. It's more of a comment on the questions. Hey guys, if we can keep questions on the Q&A, that'll be a lot easier to cipher through.
Um, the notch. Okay. On the Let's see. The image above depicts notches in a supporting beam. Notches must be less than 1/4 the depth of the member. On the tension and compression bases, the notch must be less than 1/6 of the member's depth, and the notch length must be less than 1/3 of the member's depth. Notches are not permitted in the middle third of the span or on the tension face of members that are greater than 3.5 inches thick. So basically what this comes down to is your beams should really not be notched, especially on the deck. There's really no reason to notch a 3.5 inch thick beam on a deck, on a deck post. You're going to have space above it, you'll have space below it. I think this more or less refers to structural, like your house structure. But I mean, obviously, I think there's probably going to be instances where you might see this, but I see this very, very rarely where there's a need to notch a beam or a girder. But just keep that in mind that if you do see a notch, I would just reference this diagram, take your measurements, take your pictures, and do the math. If you want to do it on site, by all means. But if you need to take it back to the house and make sure that the notches and the cuts meet the minimum standards, I would highly recommend it. This is probably what you're going to see the most of as far as notching and stuff when it comes to beams, or I'm sorry, joists. And this here we go. So this is kind of my mock-up, and I haven't hit on this very much so far, but I just did want to point this out to you guys. So on this mock-up, this is going to be mainly for a ledger. And I'll just point out a couple of things here real quick. So coming from this way, so this would be like the edge of the deck. This is a 2x10 true length is a 1.5 by 9 3/8. And then for this mock-up, this board is intended to be 12 feet long, right? So using this is 4 feet. This is a 4-foot section. So there would be the middle span of this would be another 4 feet, and then the end, the end span would be another 4 feet. So there would be, so you could notch, so you can notch in the tops. So this is kind of hard to see, but this is the notch, and I didn't mark this up because I'm gonna make another board, but this is basically the maximum notch that you can do in the top of the board. This over here, kind of hard to see, but this is the maximum notch that you can do in the end of the board. This is the maximum hole that you can cut. It's difficult to see, it's a pencil, but this is the maximum hole size that you can notch in this board. And then, and so that's for the notching. Now, and I think we're still going to get to this here in a little bit. And you kind of see all this. So basically the D has to deal with the depth of the board. So this is the depth of the board. So if you're looking at it when it's laying down, this is going to be the depth. Right? This is the depth. This is the length. This is the thickness. All right. So doing this math here, basically I did this math. So the true size of this is 9 3/8, which down to decimal point is 0.375. So then you take that number, divide it by 3, you get 3.125, which comes out to 1/8 or close to 1/8, closer to 1/8. And then 9.375 divided by 4 equals 2 inches and 3/8. Again, 9.375 divided by 6 is 1 inch and 9/16. So that's where I got all these measurements from. So if you have the D3, that's where you get that math. There is the 3/8 and 1, or 3 inches and an 1/8, and so on and so forth. I think you guys get it, but anyway, and then, well, while we're here, so once you're looking for your ledger attachments, so you have your through bolt or your lag bolt or your screw, your lag screw has to be 5 inches in from the end, right? And then doing the math for your ledger connections, you basically take the length of your board, divide it by 100, and then you get your span of how often you should see a ledger connection, a bolt or a screw or whatever. And in this instance, because we were doing the math on a 12-foot board, it should be every 1.5 feet. So we have a 1.5 feet, and then a lot of times you'll have a connector here, and then you'll have a connector here, and then you'll have a connector here, and it just W's all the way down the board. Oh, perfect. That was the next. Okay, so the most common cause of deck collapse is when a ledger pulls away from the band joists of the homes and the buildings. 21 IRC changes have created a schedule for fastener placements on ledgers. Older ledgers rule of thumb was the 100 divided by the joist length in feet. So that's where we got basically this math, is that you should see no bolts or no connection within 2 inches of the top or the bottom of the board, and then your connectors as they go along. So now the IRC is, instead of the rule of thumb, it actually has tables now to reference. The rule of thumb still primarily applies. It's not going to apply in all instances, but primarily. So as inspectors, if anything looks off, anything looks overspanned or whatever, If you don't have your code book on you, I would use the general rule of thumb and just, and then if you need to do your due diligence, take your measurements and your pictures, and then do the math back when you get back to your office or your house, and then verify and make sure. So, for example, assume a deck is built with a 40 psf live load. The joists are spanning 10 feet, and a half-inch diameter lag screws are used. The on-center of spacing of fasteners is 18 inches. The tip of the lag screw should fully extend through and beyond the inside surface of the band joist. So again, I think we already mentioned that, but you should always, if you're going to be if they use lag screws, on the opposite side, either in the crawl space or wherever the connection is, if you can see the, if it's visible, you should always see, the tip of the screw or more. I mean, I think what we say there's like an inch and a half or more of the screw. Something I did want to point out, and this is happening more and more often, is that attaching decks, solid lumber decks to I-joists, a house that's built with I-joists. You need to make sure that the band joist or the rim joist that they used for the house structure either has additional blocking that they put, if they use two I-joists, to make the band joist or whatever they use. There needs to be blocking in between those I-joists that then the screw and the bolts will go through. Where the I-joists are not, they're just getting more and more commonly used, and maybe a deck, especially if the deck is being put on after the house is being built and not in at the same time, that deck contractors, because around here, well, it's getting more common that you have to pull a permit to put a deck on, but that's only very recent in my area. And so whoever off the street could be putting decks up, and when they are not familiar with newer style construction with I-joist stuff, they're just running a bolt through or running the screw through. Hey, it's solid, we're good to go, and they don't worry about going into the crawl space and looking at this the deck structure. So if your house has I-joists in it, pay special extra attention to the connections for your ledger board to your house structure. Good. Here's a good point here. So the joist span, you got 10 feet, half-inch diameter lag screw. It's going to be every 18 inches versus a lag bolt. It's going to be every 34 inches. So I guess that's where the difference is coming in on the new IRC code versus the old rule of thumb. This year, in January, is when Arkansas just changed the 21 IRC code. So we're all still kind of getting used to it. This is showing that the through bolt is less than 2 inches from the edge. Again, if this deck, lag bolt, just looking at the head, you really can't tell the difference at all. I mean, I guess if markings, what, there might be a way to tell from the markings if somebody knows that for sure. More often, I always if on crawl spaces around here, you'll almost always be able to see the backside and be able to tell what type of connection that they use. But from the face of it, you might be able to tell from the stamp on the hex bolt head. I would have to look that up for sure.
Andy, we have a question on the second story deck where the ledger attaches to the floor joist of the second floor. Any tricks for determining if they use lag screws or through bolts?
Oh. No, you know what? No, here, tell you what, I think, let me, let's look here, we have a second. NBZYC bolts. Let's just go see if we look up the, right, the grade and material of the bolt, how strong it is. No, this is just my very quick search on my phone here. The markings only determine what grade it is, what the metric is, and what type of metal it is. So I don't have, and maybe somebody on the webinar does have a trick, but I do not know of a good trick to be able to tell the difference. I would say, well, if you can tell that the deck was built after the original construction of the house, and barring any remodels, I would say it's almost always going to be a screw, right? Just because you would have to completely open up the interior of the ceiling from the bottom floor to the second floor to be able to make those connections. And then depending on the spacing between all of them, you would have to open up basically that whole ceiling, the whole length of that ledger board, if you were going to use bolts. It's entirely possible to use bolts, I guess, if you're gonna do that. But from coming from construction, and if a customer is hiring you to put a deck on, and you come in and tell them, okay, I'm going to put bolts in, or I'm going to put bolts in, and I need to cut out all this, and it's going to add another, $10,000, $20,000 to put this all back together, and then to repaint, retexture, and all that good stuff. More than likely, they're going to say, well, is there a cheaper option? You're going to say, yeah, I can use screws, and more than likely, they're going to go the screw route. Now, if it's being built during construction, or during the original construction of the house, there's no true definite way to answer, I don't think. Let's see if anybody has a. It has to be lag. Yeah. Bingo. Try to loosen one and see if it backs out. If it doesn't, it's probably a bolt. Lag will thread back, or lag screw should thread back. Newer fasteners may be recognizable as timber lock, etc. Yeah, all these are great recommendations. Talking about backing screws out or backing lag bolts out, you can definitely put some pressure on it and see how that pressure feels to you. I definitely wouldn't back it out too, very much at all. But if that's what you want to use, try and identify. Half-inch lags or bolts with washers on the surface. Always need washers on the surface, and making sure that the bolt is not countersunk or countersunk or pulling in. Where if you're using a bolt and you over tighten and it pulls into the wood. So the whole reason behind all that really is that the intended structural integrity of a board is intended at its manufactured state. So once you start to break the surface of that board, you're lessening the structural integrity of that area. Now that's if we were just talking about this one bolt and it was pulled in or countersunk a little bit, not a huge deal. But if you're looking at every structural bolt is countersunk or sucked into the board, you might start to see cracking along those areas. You run the risk of having potentially, cracking that wood member and lessening the structural integrity of that member. And well, I know we're going to get into this again, but we're missing flashing up on top here and below, especially if this is a framed below the ledger. But we're going to get into the flashing here in a second. Oh, over here on the right-hand side of this picture, excuse me, this is a washer that's integrated into the bulkhead. So really, as long as as long as you have something there, an integrated washer, isolated washer on its own, as long as something is there that's wider than the hex head, should be adequate. Here's one that is been pulled through, a little too tight. Nuts not fully threaded. Yeah, just needed a longer bolt. And I don't know what this is attaching to, but definitely not completely threaded. Very easy for that nut to, as somebody walks on that deck, from the vibrations of people walking back and forth, wind from storms, all of that stuff. Those nuts can back out on their own. It actually looks like this one is actually backing out on its own. That top one, you have a little gap right there.
We got a couple questions, Andy.
Oh yeah. Our current standards to build decks as freestanding so as not to rely so much on the ledger. Yes. Well, it's becoming more and more popular. I think as more and more deck failures are being reported on in the news, people are sharing on social media, it's becoming more and more standards. More and more cities, AHJs, are going to freestanding decks. Now, not all of them. I mean, here we still allow for ledger attachments and not freestanding, but it's getting, as more and more people are being hurt, damaged, and it was probably all happening before, but with the media and with social media and the media being on the 24-hour cycle, they're picking up everything all the time, and so it's getting more and more in people's faces. So the standards are slowly changing. Are you seeing ledger lock screws as well? We are not seeing ledger lock screws here, but I don't know if you guys are up in the Northeast. Do ledger board fasteners have to be staggered top to bottom? You know what? I think. Let's see. Diameter on center spacing. I don't know what the new 21 code says about that. I do think they have to be staggered though, because if you don't stagger them, then you run a high risk of cracking along the bolt connection location. So I do believe they have to be, but I will definitely double check and make sure that they do have to be staggered. Brian, yes. Yeah, so like these, this would be technically wrong if it's not staggered. Okay. Yes, ledger board must be attached directly to the floor band or framing. It cannot be on the top of siding, stucco, or brick veneer. We see attachment to brick veneer all the time. Again, it just harkens back to I know we a lot of our contractors right here. So a little backstory: my area is growing so fast. We don't have enough qualified contractors in our area. So basically, and that goes for our code inspectors too. We just don't have enough, and enough that have enough experience. And so a lot of stuff is getting missed all the time. So we're getting decks attached to brick all the time. Simpson Strong Time makes a hanger now that allows for attachment through brick veneer. I'm in your area. Oh, right, thanks. Can a ledger board be attached to the house over the siding, or must the siding be removed? Siding must be removed. So yes, you cannot attach directly to the top of siding. Siding must always be removed. Well, there's a lot of factors that go into why the siding must be removed. But let's say, well, the first one is siding must be removed so that you can correctly flash the ledger. If the ledger is not flashed correctly, then you run a very high risk of that water pouring back into the wall structure. So yes, and especially if and this is only on framed walls. So if you have, let me see, let me back up here. So if you have like vinyl siding that comes down, then you have your deck ledger, and then that's connected to your concrete foundation block or your CMUs or whatever. You don't have to flash when you're connected to CMU or concrete, but you do have to flash in every other instance. And in every other instance, the siding must be removed so that you can flash correctly. If you have framing below the ledger or behind the ledger, then both the top has to be flashed and the bottom has to be flashed. Again, we don't see that here. I almost always, we barely get flashing on top of the ledger, and even in our new construction. And so I'm constantly calling this stuff out. Can the ledger be attached to brick veneer? So I guess what the gentleman Chris makes a hanger now that allows it. So I'm going to have to look at that. I would be super interested on how they are attaching the brick veneer connection with the ledger to the brick. So that's something I'm going to have to take back and take a look at. What if the siding is just painted texture? Do you have to remove or cut the board to get to the framing? Yeah. So when it comes down to it, you have to have the structure of the deck attached to the structure of the home, and siding is not structural. And again, with the flashing, those all go hand in hand. Is that you have to attach the structure, and then to protect that structure, you have to flash it. And when you don't attach the structure, and you don't attach to, and you don't have flashing, then you run a very high risk of that deck ledger pulling off of the home. Block walls, attachments need to be sure of filled blocks or not. Where the connections are attached to the block, that cavity should be filled. Now, like we were stating before, Simpson Strong Time makes all kinds of different things, and they might have a special connector that allows you to attach to the cavity of a CMU block, but I am not familiar with that. So that if you are attaching, we definitely need to have that built, because the CMU block, it's intended to hold or to support vertically, right? So the face of that block, your block wall. So if you're going to pour a foundation wall with concrete or a footer, you're looking at a solid 4 inches thick, 6 inches thick. And so if you're putting that horizontal stress on a CMU block, you could potentially break the face off of that CMU block without it being filled. So there might be a connector out there that allows that, but as far as I know, that block has. And I think where there's a diagram here, second things. Ledger cannot be attached to a cantilever floor unless the cantilever was engineered to support the deck. Pass through to the rim joist, does not rely on the brick. Okay, yeah, that makes sense, Kevin. Yeah, and that's what I would expect. Very good. So the ledger cannot be attached. Yes. So we again see this all the time. We don't have. I don't know if I've ever seen a cantilever portion of a house that's ever been framed out to hold the deck correctly. So I would more than likely you're going to see this type of connection. Like I said, I've never seen it framed out correctly to be able to hold that. And the times that I have called it out, every time I get called back out to go do a follow-up inspection, the contractor has come out and framed it out correctly. So it's always been a plus for the buyer. So here's just a good diagram of framing out around a cantilever. Double headers, little joists, everything basically doubled up with hangers, blocking, all of the standard connections for the actual ledger board. Yeah. Thanks, Chris. I appreciate that. Oh yeah, look at that. We did pointed that out. So this one, so they did flash around it. So at least we got flashing on there, huh? But the main issue is that the cantilever on a house was not intended to hold all of this weight. So if you're going to put a 200-pound person every 2.5 by 2 feet right on this area, that band joist of that cantilever was never intended to hold that amount of weight for that span. So it's easy failure. Same again. More incorrect framing. Image depicts a ledger attached to an overhang. Decks should not be attached to overhangs. Yeah, again, likely was never engineered or designed to be like this, or to have, well, it might have been designed like that, but maybe it was not installed correctly to have, the ledger attached. And obviously, building science, building practices and construction has changed drastically over the last, even over the last 10 years, it's changed drastically. So this might have been acceptable before we knew better. So it is our job, as inspectors, come out and say, hey, this might have been okay at one point, but you run a very high risk of the weight of the deck. If you put a ton of people on here, or a 200-pound guy every 2.5 by 2 feet, that the ledger board that this deck is attaching to the band of the house might not hold, and it's our job to point that kind of stuff out and recommend it for upgrade. All right, so now we're getting into the flashing. This is what we see a lot of. Yes, so this ledger on the left is directly attached to the siding. So I guess one of the main issues is that without this flashed correctly, without a flasher or without ledger flashing, water is going to come down and hit these bolts, and it's going to follow that bolt into the siding of the house, and or it's going to get in between the ledger and the siding, where it connects up above on top of there, and water is going to naturally flow down in between the ledger and the house here. It's going to come into contact with these screws and these bolts, And it's going to follow those bolts into the house, into that siding. It's going to deteriorate that siding, which is part of what's holding that ledger up, and then keep flowing, keep flowing into the house frame. So crawl spaces. Now this is obviously there's room back below here, so this is probably all finished out below. But if this were a crawl space, I would look on the back side of that, and almost always you're going to find some type of moisture staining. Whether it be coming through where the bolt's coming through, or if the siding has rotted up above on that connection. And I will say a lot of times maybe the siding has been pulled off up above there, but it hasn't been pulled off back behind the ledger. So all of that is just leading to moisture intrusion points. So you're going to have, and then you're going to have this the whole length of that ledger. And so you're going to have all these penetration points coming along. And so you want to pay special attention to the back side of these walls, these ceilings, or in the crawl space if you have access, and look for moisture, any type of moisture staining along those areas. And again, probably prodding the siding, especially if this is wood siding, using your probe and gently probing the siding around here and seeing if it's soft, because if moisture is getting back in behind that siding and the back of that siding is not painted, it's going to be rotting from the back side to the front where it is painted. So the front could look completely fine, but until you prod it, it might be rotted back behind. The paint is what's keeping it together. Let's see, over here on the left, this looks like stucco. And it looks like we have ground contact over here. So probably we have, so, the stucco we all know is notorious for hiding water damage. And so looks like we have maybe a lag screw with a hanger. Yep. Attached directly to the stucco. And stucco, if this is stucco, water is going to be pouring down in between this gap right here. It's going to be coming into contact with that lag screw there, and it's going to be coming into the and it's going to follow into the band joist of the house. So ideally, the stucco should be cut back, flashing installed underneath, and then over the band joist. And then I'm not sure, that might be a window well or whatever. So yeah, definitely some points for moisture intrusion here. All right, this is where we're going to get into filling the CMU voids with concrete. So this is your concrete wall, and ideally, it's kind of like, and I would say first off, I never see caulking. If you have a band joist connected directly to a concrete wall or a CMU wall, I have never seen caulking at that joint, which is important, and that you have a gap there. So it's kind of like, having the correct gaps between the deck floorboards and having that self-adhering flashing or whatever that's across the band, is because once this starts to deteriorate and warp, and you get different expansion contraction throughout the year, and that's going to cause gaps, in your band joist to your concrete, and water is going to get back in behind there, and it's going to start to rot all that stuff out, because you're not, it's not getting, and on top of that, concrete never really, ever really dries out completely. So it's soaking in water from rain, or from high humidity. And without that caulking bead there, you're just allowing more moisture to get in between your band joist and your concrete wall there. So the name of the game is keeping water out, right? Always keep water out. And if it gets in, let it out. So those are the two mantras of inspection and construction. We're always trying to make sure that Water stays out, but if it gets in, it has a way to get back out. So again, we have 1/2 inch expansion anchors embedded 2.5 inches into the concrete. If you're unfamiliar with these, and I did not buy any of these, but I've seen these a lot, and it's amazing how much weight these guys can hold. But basically, it has just it's a bolt that has a like a bell end on the end, or a bell end, and then a little collar. And so you drill your hole, you tap the bolt in, and as you tap it, that metal collar flares out on the end, and it fills that concrete hole, and that allows you that positive connection to that concrete. Pretty cool engineering on those. I've done some wild. It's amazing how much weight those things can carry, and in all different directions, vertically, or horizontally, from up above, all that kind of stuff. Pretty neat stuff. This image depicts a ledger board and a band joist sandwiching the structural sheathing. Sheathing is permitted to be wood structural panel, gypsum board, fiberboard, lumber, or foam. Sheathing is permitted to be wood structural panel, gypsum board, fiberboard, lumber, or foam sheathing. The 21 IRC table for ledger connections allows up to 1 inch of open space between the house band and the ledger. This provides for wall sheathing and or drainage and ventilation. It is not intended for cladding, so no siding. Up to a 1/2 inch thickness of stacked washers are permitted to substitute for up to 1/2 inch of allowable sheathing thickness when combined with wood structural panel or lumber sheathing. Removing the cladding and reinstalling it properly around the ledger depends on what type of exterior wall covering is installed. So that the 1/2 inch thickness of stacked washers, that allows the contractor to be able to marry up all of the different materials that are intersecting at that point, so that everything looks good. You can flash everything correctly. It can potentially allow for water to not be trapped at that connection point. Not that you probably will never see those washers, but you might be able to see a gap back behind the ledger if there is any say washers or spacers. Spacers. All right. The IRC requires decks supported by the attachment to an exterior wall to be positively anchored to the primary structure and be designed for both vertical and lateral loads. Attachment only to the band joist may not be sufficient for lateral loads. Positive anchorage of the deck joist to the house floor framing, as shown in the figure above, addresses this potential failure. You guys might see these in your area. We do not see these tension devices in our area. I would love to see them. I think the more connection, the less likely it is that the joist is going to fall or it's going to pull away. Rot is less of an issue in this scenario. If the band joist, if the flashing fails, so there's a super thin flashing out there that is currently acceptable, but it rots and rusts very, very easily. And so we see it where it's just completely gone a lot of these times. And so in that instance, if that flashing were to be gone and it were to allow the connection of the band joist to rot, then you still have additional connection. So I would applaud anytime I would ever see this, but we have never seen it. I'm seeing and hearing a lot about code. While I try to stay on top of that, plumbing lecture still on it is not an SOP. Once you start citing code, you're opening her up. Yeah, Tim, this is for you to be able to understand what you're looking at. I would never recommend talking code to a client or anybody, but it is very important for you to understand code and how things are constructed and why they are constructed, so you know exactly what you're looking at and what to look for. So yeah, I agree. Don't speak code to your client. We're not code experts. We hear that stuff all the time, but I do think it's imperative that you educate yourself on code so you know exactly what it is that you're looking for. Let's see. Oh, there one is in the wild. Where lateral load connections are installed at the deck, the inspector should observe hold-down tension devices installed in at least 2 locations per deck, and they should be installed within 24 inches of each end of the deck. Each device should have a stress design capacity of at least 1,500 pounds. Yeah, again, I would love to see these in the wild. I really, really would. We're not quite here yet in Arkansas, but hopefully it's coming soon. Yes, the deck does look, it is integrated into the siding. And again, so more than likely this is framed, and so yes, it is missing flashing here. We do have flashing up above, and this does look like it might be that super thin flashing that I was talking about that easily deteriorates. So I think the deal with that flashing that easily deteriorates it's first off, it's super thin. Second, the coating that's on it, if there is any scratch in that coating, if there is a dent in that coating, if they damaged it at all during construction, then it's, once you lose that protective coating, it's going to start to rot from wherever that lost that coating, and it's going to start to go out. So I think that's why we see a lot of this flashing that has been rotting away over time. You are seeing them in new construction, and I'm a little jealous. I would love to see them. Here's another example. I think this is probably more likely what we're going to end up seeing more often is this type of connection. The previous connections where you have to have the all thread that goes all the way through and connects all the way through. That just seems like it's going to be a lot of work for a contractor. And I think we all know that a lot of times it always goes towards the easiest, the cheapest, and which I think is going to be more in line with probably this device here. This attachment was approved by a city inspector and without comment on the crack. Yeah. So, and here we go with filling the CMUs, CMU walls. So, again, we should have caulking, 2-line ledger, epoxy acrylic anchors. They do have these really awesome. It's a glass tube filled with a 2-part epoxy mix, and basically once you drill your hole, you put that glass tube in there, and then you put your bolt. You put your bolt in there. Once you tap it in there, it breaks that glass tubing, and that epoxy mixes together, and it creates that chemical reaction. And then it expands, kind of like your standard expanding foam. But it has to be rated for, and obviously I think anything in that instance would be rated for that connection, and that's not something that we would ever see. But it'd be cool to be a product. Hilti makes that product, yeah. All right. Image depicts the ledger board attached to hollow masonry. When the ledger is attached to hollow masonry wall, the cell should be ground. So something I just saw the other day on a new construction house is okay, question is joist tape ever a substitute for metal flashing? I would say no. I mean, I guess it's possible. It's possible, but your joist tape would have to be like 6 inches wide at least, um, in order for it to, in order for it to go up behind the siding and then, go horizontally over the ledger and then come down over the ledger. Or I guess you don't necessarily have to come down over the ledger, but in order to provide enough protection, you would probably have to use 6 inch wide tape, um, in order to have 3 inches, 3 inches up the wall and 3 inches down. I guess you could, as long as everything is layered correctly. If you have house wrap, it's underneath the house wrap, the siding goes over. As long as everything's layered correctly, I think you could probably use it. I don't see it very often because I bought a roll of that flashing tape the other day, and for like it was incredibly expensive versus using metal flashing, uh, is like half the cost. So I think you could potentially use joist tape, but you would have to make sure it's white enough and that it's correctly layered. Um, let's see, not here, metal or improved plastic ledger flashing. Um, yeah, okay. I think we've never. So going back to Robert, the joist tape substitute for metal flashing. I would say it's possible. It's definitely going to vary depending on your AHJ and all that. But the theory is possible. Uh, but like I said, I think it would be cheaper to use metal flashing than it would be to use the the correctly sized. I'm going to say joist tape. All right. 3 ways a joist can be attached to a ledger: um, notched in, not notched in, um, and then uh, obviously you have joist hangers and blocking. Obviously, this is missing all of that, and it's end nailed. So end nailed is no longer allowed. I would say no longer. I'm sure it was allowed at some point in construction, but is not anymore. Um, Now you have to have joist hangers or blocking. So blocking that extends from one joist to the other is then nailed from the ends on this side, and so that way it creates that positive connection all the way around. Um, yeah, so there's a lot of things going on here, but yeah, you should see either toe nailing, joist hangers, or blocking. Toe nailing, I don't think is allowed anymore, but that's fairly recent that toe nailing is no longer allowed in this instance. So I think this is mainly for just showing how your bolts are not alternating. They're in the same plane, which can lead to a horizontal crack that goes the length of the wood. Um, I think you guys probably might see this stuff all the time too. Is that I don't know, for whatever reason they're not putting the correct or not putting enough mounting hardware in your mounting holes. And then when you have older decks, it's very common to see nails backing out, see mixed materials as far as your connection types. You might see drywall screws, non-galvanized materials, all different kinds. I mean, every fastener that you can think of. You go down the Lowe's aisle, and every fastener on that wall you'll probably see in a deck joist hanger. So you want to pay special attention to your materials. Make sure they're all steel. Use your magnet. Make sure that you're checking those. And then another thing that we're seeing, and we see this even on structure inside of homes where they're cutting the joists too short. And so, the joists are barely, you're like the joist is halfway on the joist hanger, and that is obviously it's incorrect. If you look at the Simpson Strong Tie website, you know, I think there's only a quarter inch gap that is allowed from the joist to the beam. Joist hanger is the wrong size. So here's a good example of joist hanger sizes. So talking about joist hanger sizes, this joist hanger size is rated for a 2x10. This joist hanger size is also rated for a 2x10. Oh, here, actually, let me put that on the other way. So you can see the difference. So, yeah, there's that guy. And there's that guy. Both of these are rated for 2x10. This guy is rated for 2x8. So you got to be cautious of calling these out. You can always look. I don't know if you can read that. Probably not. You can always look on the bottom of the joist hanger, and it'll give you the model number. This is an LUS 26Z. You can look up the Simpson Strong Tie manufacturer installation instructions, and it'll tell you exactly what it's rated for. But yeah, it's very misleading sometimes when you're looking at joist hanger depth sizes, and when it compares to the size of the wood. Just keep that in mind when you're looking at hanger sizes. Oh, here's a good example of, and actually here, so this is the same hanger. Oh, golly, trying to zoom in. This is the same hanger that I have that I just showed you guys. So you're using galvanized connectors. Obviously, the joist is not, first off, it's angled. It cannot be angled at all. And there's definitely more than a quarter-inch gap on there. And then obviously the nails are not even attaching to anything. And I see this on structure inside of homes. I see this on decks all the time. It just comes down to quality of construction. So keep an eye out for those things. Here's another good example. So this is an angled joist hanger. Most of the time, I rarely see angled joist hangers. Almost always you're going to see this stuff toe-nailed. But again, if you do have a joist hanger, quarter-inch gap. So obviously this is more than a quarter-inch gap when it comes to this location. So keep an eye on that. This one is harder to see. You know what? I think it's I might be wrong. It might be an 1/8 inch. I might be telling you guys wrong. I'd have to look up the installation. Either way, you can look up the requirements for Simpson Strong Tie. Look up the model number, and it'll tell you exactly what's allowed. Here's a good example. Definitely more of a gap than is allowed. The screw it's barely penetrating through the edge of that joist, and does not meet the Simpson Strong Tie standards for sure. So that is something that I would highly recommend. If there's ever a question and you have a manufactured product like Simpson Strong Tie, go through and read their installation instructions, and almost always you'll find things that you can use in your inspection to verify if it's being correctly used or not. It'll tell you what connectors are allowed. It'll tell you what gaps are allowed. It'll tell you if it's allowed to be modified or not. Some of Simpson Strong Tie stuff is allowed to be modified, but most are not. So keep that in mind. I've seen where they had they tried to use a double hanger. So if you were going to have, two joists, and instead it's like they didn't want to run to the store and go get one, and so they used it for a single hanger, and they just took a hammer and hammered it down, and then connected it to the band joist. Half-inch gap on LUS hangers. Thank you, Jordan. That was right. Looks like the joist is on top of the siding. So I would say, but there's concrete down here. So this looks like concrete, but definitely siding up here. So I would imagine in this instance, this band joist is likely attached to, this ledger board is likely attached to the band joist of the house. So yes, you are definitely missing flashing here. Now, not necessarily missing flashing down here if this is concrete. I believe this is concrete. Now, talking about screws. So I looked on the Simpson website, and there are structural screws that are allowed. It is very difficult to tell if they are structural screws or not, though, which is why nails are preferred, especially galvanized nails. So I had that same question, Paul, thinking that screws are not allowed at all, but they do make structural screws that Simpson Strong Tie allows to be attached. But it is, again, it's very difficult to tell if they are structural screws or not. All right, so man, that picture on the left, there is so much, so much wrong going on there. You have screws are being used in the end cut of the wood, not allowed. The joist hanger was bent to, originally it was bent here to allow to attach to a ledger, and it was bent, not allowed. No, the siding was not cut back, no flashing, tons and tons of stuff going on here. Same thing over here. The stringer hanger is, well, I don't think the stringer hanger is good here, but well, it's obviously not good here. But this I don't think was modified outside of scope. But Simpsons makes a hex screw for joist hangers. All right. Yeah, that one on the left is that's a fun. Yeah, and this is not even made for this situation. This hanger is made for roof support overhangs. That's not even the correct application for that. And honestly, that looks like it's the only connection. It looks like you just have 3 screws on this side, probably 3 screws on the other side, and nothing else holding that together. And again, there's so much wrong going on with this picture, but fun times in the inspection world. The ledger above depicts ledger boards improperly supported by brick stone veneer. Ledger boards should not be supported by stone or brick veneer. Yep, we talked about that earlier. Yeah, so if you do see a ledger that is attached to brick, there's got to be some way to verify the connection into the house structure. Either with, like was mentioned earlier, those very specific connectors that allow for connection through brick, all that. All I say is that those connectors are going to have to be very long, because you know how wide brick is, and then you have the air gap back behind there, and then you have your wall sheathing, and then you have your framing, and so you've got to make that connection all the way through, because brick veneer is exactly what it is. It's brick veneer. It's not intended to be structural. It's intended to be just another type of siding. And so, if the mortar breaks down, you're running a huge risk of that ledger board pulling away. Um, Good news is we don't have to list everything. Just improper joist hanger installation. Agreed, Mark. Covers a lot of ground. Yeah, agreed. Let's see here, and then obviously this is definitely not, not good for anything. But all right, let's keep. All right, here is a great picture. Here's a great diagram of what the flashing should look like when you're attaching to basically any type of siding. This is how everything should look. Mainly because I think we've discussed this before. I thought Tension Strong Time made number 9 and number 10 various length screws. Yeah. Okay, so back to the flashing. It all comes down to keeping water out. That is the primary function of flashing, right? So if you penetrate anything on the exterior of the house is your main water barrier. If you penetrate that at all, you have to protect that penetration. And protecting that penetration is almost always done with flashing. It should never be with caulking. Caulking is a secondary moisture barrier. Secondary moisture barrier. It is never intended to be a primary moisture barrier. So metal flashing is always going to be your primary moisture barrier. Okay. I thought okay. Let's see. Do buyers retrofit ledger boards when not installed right in your area? 2x planking instead of 5. Yeah, I mean, people retrofit horribly all the time. I can't even begin to cover all of the stuff that we've seen here. It's so we didn't have really any code requirements in Arkansas until early 2000s, and so we have, and a lot of the houses that we inspect are, anywhere from the 40s to the, through the 90s, and so very, very little code regulation here. So we see a conglomeration of all different kinds of materials, methods, all kinds of, and the damage that goes along with it. And we still see, because we are lacking in such qualified contractors and qualified building inspectors, that stuff is still being built incorrectly to this day. So yeah, 2x planking, we'll see 2x planking all the time. 1.25 inches is most common. 2x planking is fairly common. It's more common on the older homes. Yeah, no, they wait until the deck falls down. Honestly, that's the way things. A lot of things go around here. They wait until the deck starts moving, boards start rotting, things start falling apart to do anything about it. Let's see. So a lot of this stuff we're not going to see during our inspection, but it is good to know all this information. And so the main thing to look at this diagram is just make sure you see visible flashing on both the top and the bottom. You have a frame structure in both top and below. All right, so yeah, this looks like it's framed below the ledger. So the biggest thing here is going to be this gap, right? So if it's going to rain, you're going to have rain. It's going to come through these boards. It's going to come down the wall that's on top of the deck. It's going to roll over this flashing, and then while this area might be good for a while because this edge is caulked, so the caulking might be good for a while, but obviously if this caulking deteriorates every 3 to 5 years, this is going to have to be recaulked. But the main issue is going to be this end joint, this butt joint right here. So water is going to roll down, and this is completely unprotected. So this is a clear throughway for water to get in back behind the siding that's below here. Which again is why you want flashing all along the bottom of this. Otherwise, you're just inviting water to get into your wall structure. And you can see here that the bolts look good. They're this looks to be within 5 inches of the end, so you're good there. They're alternating. They have washers. Your joist hangers all look pretty good. Flashing looks pretty good. Just this butt joint. No bueno. Roofing felt used as flashing. You know, you can see the tear in the and I was going to say flashing in the roofing felt over here. Again, you're inviting water. You don't want to do that. And then you have mixed materials. You have looks like a deck screw here, and then you have galvanized nails. Galvanized nails. Oh, deck screw there. You know, and this looks like a lot newer band joist too. It looks like new caulking. So this looks like it might be a fairly new deck, even though we have looks like older deck boards and roofing felt. So interesting application. All right, so let's give this guy a shot.
Oh, hi, I'm Ben from InterNACHI, and I'm standing in front of the InterNACHI House of Horrors in Colorado. It's an entire house with 1,000 defects built under our roof. In this video, we're going to learn a little bit about deck ledger flashing, and we're also going to refer to the International Residential Code. So get out your textbook. Let's take a look at this demonstration of deck ledger flashing. Okay, so the International Residential Code of this code book, section R703.4, flashing. It says approved corrosion resistant flashing shall be applied in a shielded fashion in a manner to prevent entry of water into the wall cavity or penetration of water into the building structural framing components. And self-adhered membranes could be considered flashing according to some standards. So that's again R703.4. So let's go over some of the components of this little demo here, the deck ledger flashing, and then we'll talk about the flashing itself. So this is the poured concrete foundation with some grass next to it, and there's a sill gasket, a sill plate on top of the foundation wall, joist, floor sheathing, stud wall, exterior sheathing, and this is the house wrap. And this is also considered the drainage plane and the water resistant barrier. This is flashing here, so this would be installed next. This would be below the ledger board, and the membrane would be installed this way on top of the edge of the flashing, and then the ledger board is installed. So the top edge of this metal flashing down here would be protected by a shingle-like installation of the membrane waterproofing. And then the ledger board, it's got to be at least a 2x8. And then flashing in the top. And then to cover that top edge of the metal flashing, we have the membrane once again. It's adhesive, right? Now, to stop, to continue that shingle flashing later, what we did was we house wrap and feathered in this top membrane, which is covering the top of the metal flashing, and it's adhered underneath the house wrap, and then this incision, this cut, is taped over. So this is flashing, metal flashing, metal flashing. And you got your floor joists attached with floor joist hangers to the ledger board. So in the code book, it says applied in a shingle-like fashion, right? A manner to prevent entry of water into the wall cavity. Well, I think of shingle-like as to be like this, where we're referring to asphalt shingles of a roof. and the bottom layer is there. And then this is shingled on top of that, shingled on top of that. So everything is diverted away. It's shingled, it's overlapped in the correct manner. There isn't any open edge, right? To allow water to come in. Everything you can imagine water coming down in a shingle-like fashion. Everything's installed in a manner to divert water away from the structure itself. So when you're looking at the installation of deck ledger flashing, the important part is it's installed in a shingle-like fashion. So let's look at this a little bit up close. Again, the metal flashing overlap with the membrane. The deck ledger is attached, and then at the top, let's remove the floorboards of the deck. You have metal flashing here. The top edge of the metal flashing is overlapped by another sheet of membrane, and then that incision where it's feathered in and taped over. Now, the actual installation of all the shingling materials isn't detailed in code at all. It's really construction standard best practices, things like that. The code just says applied shingle fashion in a manner to divert water away. So there are a few resources where you may see some differences between this area here in particular above the top flashing, but the idea is to shed water away. Another detail is how does this flashing, how do we get this installed properly? And there are many recommendations. Code is silent. Some resources say that the contractor should make some incisions on either side, on both sides of the floor joist, and bend this down. Some say that this flashing actually should be installed behind the ledger board. That doesn't make any sense. Another one says it should be lipped over, and that would mean bending the flashing on site. I think cutting the flashing and bending the flashing is too much. It introduces too much room for the human error with the contractors. This is actually very easy to install, and you would actually pull the floorboard away just a little bit to give it a little bit to drain. That mentions water resistant barrier, and it says the water resistant barrier in section R 703.2. It's one layer of number 15 asphalt felt compliant with a certain standard or other approved water resistant barriers. And that's the waterproofing membrane. So this material is compliant with code and best practices as well. There are a bunch of defects that you probably see. The fasteners aren't installed properly, and the actual joist hangers were cut. They were actually for 2x10s, and this is a 2x8 installation. Now, one of the things while we're here is clearance to grade. If siding was here, let's just assume siding is here, it would be installed below the bottom flashing, and you can think of 2, 6, and 8. What you want is 8 inches from this piece of wood. Any wood seal on top of the foundation needs to be at least 8 inches away from the ground, unless it's preservative treated. But in general, I think of it as a home inspector 8 inches. If there was siding here, the bottom of this siding should be at least 6 inches from grade. And if the ground was a walking surface, like a sidewalk, a hard surface, you need at least 2 inches. See code book says section R 317.3.1 talks about the fasteners, and then we talk about also half-inch diameter bolts if the fasteners of a ledger board is full bolts. But the fasteners here includes nuts and washers for preservative treated wood shall be of hot dipped G185 zinc coated galvanized steel, stainless steel, silicone bonds, or copper fasteners. Here we have fasteners attaching the ledger board to the structure. Here, there's one there, there's one hidden over there, and they're actually, we picked these up at Home Depot, a ledger lock. The ledger lock actually says the coating on this fastener has been tested and wood treatment chemicals such as ACQ, and found to provide equivalent protection to code approved hot-dipped galvanized. So they're saying it's equivalent to the code requirements. And obviously there's a defect here. This isn't sunk in all the way. This is sunk in too much. And that one is actually becoming the joist, which isn't a problem, except for the joist now is not fully inserted into the joist hanger. The ledger board to have a clearance of 2 inches. So you can't have a fastener within the top 2 inches of the ledger board and the bottom 3/4 of the ledger board. If it's too close to the edge, the idea is that the wood will crack. So the top needs more meat of the wood. So there's a 2 inch.
Looks like we lost some audio.
Steel
Andy.
gaskets. In this section,
Sorry.
fastener has been tested in wood treatment chemicals such as ACQ, and found to provide equivalent protection to code approved hot-dipped galvanized. So they're saying it's equivalent to the code requirements. And obviously there's a defect here. This isn't sunk in all the way. This is sunk in too much. And that one's actually becoming the joist, which isn't a problem, except for the joist now is not fully inserted into the joist. The ledger board to have a clearance of 2 inches. So you can't have a fastener within the top 2 inches of the ledger board and the bottom 3/4 of the ledger board. If it's too close to the edge, the idea is that the board will crack. So the top needs more meat of the wood. So there's a 2 inch clearance. You can't have a ledger fastener within that top 2 inches and the bottom 3/4. This one here is getting a little close. So it's one of the things you can keep a look at. Oh, and also 2 inches from the end. So if this was an end of a ledger board, you don't want a fastener at the very end, it will crack it. And code mentions the seal gasket, and it's in section or table M1102.4.1.1, and it's really for air leakage. There are tray plates and things like that, but air leakage is recommended to stop air leakage. There's also recommendations from other sources about putting spray foam sealant or glue here, 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 and there, just to stop air leakage. Now let's take a look around the other side here. And we can take a look at bolts that attach the ledger plate, that attach the steel plate to the poured concrete foundation. 1/2 inch bolts need to be embedded into the poured concrete foundation at least 7 inches. It's impossible for a home inspector to see that. You can look for defects, a loose washer here. You can look for spacing as well of the fasteners, and you want the fasteners within the middle third ideally. You don't want, again, a fastener on the very edge. You can also take a look at the ledger board fasteners as they come through the band joist. The tips are required to go through the band joist, and I see one here, so that's good. There's a gap in the floor joist here. Looks like a nail was missed there. So that's a quick training video on the deck ledger flashing. Remember, shingle-like manner, and this demonstration is always here at the InterNACHI House of Floors in Boulder, Colorado. Feel free to come on by and take a look for more defects, and I'll see you in the next video. Bye.
All right, sorry about that, guy. I optimized it. Somebody's suggestion I optimize the video like almost 7/8 all the way through, so I hope it got better at that point, but I'll remember that on the next one. All right, so moving on. Cantilevers, pre-2021 cantilever decks. Joist should be cantilevered no more than 1/4 of the joist length and 3 times the joist width nominal depth. Both conditions must be true. So what if you have a 2 by 12 joist, then the cantilever could go out to 36 inches. 36 inches equals 1/4 length and 3 times the width. But this standard, length divided by 4, is no longer used according to the 2021 IRC. Again, it's going to a table basically in the IRC, which I think is on the next. All right. So here's a good diagram of your standard deck construction with a cantilever. You got your joist hangers, your ledger board, your 6x6 posts, your girder that's supporting that post, your footing is dashed around there. And then, okay, so here's kind of the math. The length of the board divided by 4 is going to give you how far in your 6x6 post can be, and how far back your girder can be. Right. I'll do a little mock-up on this next round, but you put the last cantilever side up for it and take a picture. Absolutely. Again, it's kind of the rule of thumb still mostly applies. So you can still kind of use that to get an idea of what you're looking at. But if you want to, take your pictures, take your measurements, and then get back and do the math, or look at the table, which is going to come up here in a couple slides, and then figure out, is it correctly cantilevered? Are the distances right? All that kind of stuff. And obviously, if there's nothing, as we go back, if there's nothing crazy, if there's not a huge sag in the end of this cantilever, if everything looks like it's been working right, the deck has been up there for 10 years, there's no deterioration, there's no damage, you look down the length, everything is still plumb and level, then you might decide not to call it out. If there's nothing actually wrong with it, in that specific instance, it might be working like it's supposed to. But if there are issues that you see, then that might be something that you use to, make your evaluation and make your determination on, what exactly is going on, what they need to do about it, who they need to call, everything that a home inspector does. I'm not sure on my side, but the YouTube video sound was distorted to the point of not being able to hear words at all. Yeah, I optimized the video at the very end, and that might have been my bad. I'll know that going forward, and I apologize for that. Does the joist length include the cantilever part? No, it's available for viewing amount of time, but maybe it should be integrated into the webinar. Thank you. Okay, so does the joist length include the cantilever part? Yes, it does. Yeah, so you can see here up on the left-hand side of the screen. So this is the length of the full joist, and then you do the math using this number, the length of the number, to find out, divide the length by 4, and then you're going to get your cantilever length here, and then how far over the support post can be. So, this is a cantilever, and this is a cantilever. So you want to make sure that you're within those specifications for for this instance, for this mat. If you're going to use that standard versus the table standard, which is here. So you can see here. All right, let's be conservative and round down from 13 feet 7 inches to 12 feet at the joist backspan. The maximum cantilever is going to be 3 feet. So using spruce, pine, fir, 2x10, joist spacing is 13 feet 7 inches. And then you have a 3 foot cantilever, right? And then using the old math, the length divided by 4 on the 12 foot span, 12 foot span divided by 4 is 3 feet. So it still works in this instance, but now there's a whole table dedicated to it. Yeah, so just real quick on you guys, I thought maybe muting my mic would still allow the video to play, so that's why we lost audio there for a second. I thought maybe that would help because maybe we were getting feedback from my mic, but when I muted, you guys didn't hear anything. So we'll work on that, and I know we'll have it correct on the next one. I apologize. All right, next. All right, so this cantilever, way too long, way too long. It should be like probably here, maybe. I don't know. I don't know the full length of this. It's a great picture back, but definitely too long. You can see a little bit of a sag occurring there. So, just keep an eye out for that. I imagine if you were, so there's a lot of things going on with this railing and the seating and all that kind of stuff. But if you were to be out on this ledge, I'll bet you if you were to hop up and down, you would get some really good deflection going on up in there. Not that you should, but just saying, that's kind of what we're trying to stay away from. All right. How far a 6x6 used as a beam cantilever? I don't know. Not far. Okay, keep going. All right, bracing. Decks greater than 6 feet above grade should have diagonal bracing from post to girder and from post to joist. So, post to girder, well, girder, post to joist. So, and 2 feet by 2 feet. All of this is to stop that sway of the deck. So basically, what it comes down to is if you're coming up and you're starting this inspection underneath this deck, it doesn't hurt anything to put a little stress on some of these posts and see if that deck is swaying back and forth in any direction. There needs to be additional bracing added to this deck. This is just the standard bracing, and you can recommend that. Recommend a licensed deck contractor to add additional bracing to stop the movement of the deck from side to side. All right, share. Thank you, Tanisha. All right, support columns way off too. Yeah, going back over here. Well, anytime you have, we primarily deal with wood. In this instance, we're dealing with deck, and it even looks like this is an adjustable support post here. I think that's a screw post. So I think there's a lot of stuff going on here. But anytime you're dealing with metal, metal spans are a lot greater than wood spans. So I would say do your due diligence if you want to take that measurement, figure out, and see if you can see any marking on the metal. Do a little math, do a little research, see what you come up with. But again, it comes down to, is there defects? Is there something that could be an issue in the future? Definitely want to report on that stuff. And then decks greater than 6 feet above grade that do not have diagonal decking, so that if your floorboards are going diagonal across, then you don't have to have this diagonal piece, because A lot of times the diagonal floorboards are your diagonal bracing, right? So you don't necessarily have to have that guy, but if you don't have that diagonal bracing, I can almost guarantee you, if you push on this post over here, this deck is going to sway back and forth, right? If there's any movement at all in the deck, there should not be. Figure out maybe what's causing that sway or what's missing, and report on it, and recommend upgrade. Here's where the old hammer comes into play. A hammer can be your best friend, especially if you have a raccoon chasing you or something while you're underneath their deck, because they love to nest up underneath there. But checking your lag bolts and your through bolts and your screws. It's kind of what we were talking about before. If you're trying to determine what type of screw or what type of bolt it is, or if it's a screw or a bolt, if you're able to hit it, might be able to tell real quick. If you hit it and it's loose, you can pull it out. If it can be pulled out, I would not recommend pulling it completely out if there is any tension on it at all. But if you can pull it completely out, then it'll tell you what's in the rest of that deck and how to address it. And the inspector should note missing connectors or fasteners. All lag screws and bolts should have washers. So these guys do not have washers. You can see that they are definitely pulled in, and when they pulled in, it caused a crack. That guy, and then it looks like we have deck screws, which were not rated. For ledger flashers, ledger hangers. Sorry, joist hangers. Here. We have all of our connectors on that side. We have those there, and so it looks like we're just missing some washers. Looks like maybe this is concrete here. That might be flashing. I can't tell. Let's go next. As wood ages, it is common for cracks to develop, large cracks longer than the depth of the member, or so longer than the depth of the member. So if this is a 2x10 and you have longer than a 10-inch crack, then if we're using, we're not using the nominal. If you're using the actual, I would use the actual. So a 9-inch. Let's see, this one is 9 3/8 inches. Yeah. So this 2x10 is 9 3/8 inches. If you have a crack that is longer than 9 3/8 inches, call it out as deterioration and recommend it for evaluation and potential upgrade. And then we have just knots and deterioration, natural defects in the wood. We see this stuff all the time. Natural defects in the wood. You have a huge knot, and then it cracks around that knot. Well, unfortunately, now you've lost all this structural integrity in this guy. So I would not be surprised that walking down these steps, I'm assuming that this is a stringer for some stairs. I would bet you that there's a lot of give in these stairs when you're walking down. Large cracks longer than the depth of the member or excessive cracking overall can weaken deck framing. Toe-nailed connections are always at risk for splitting, which is generally why you don't want toe-nailing. And we see it all the time, especially on older decks where it's just, it looks like you have 100 nails on one side of the toenail and another 100 on the other. And then there's just all kinds of cracking and deterioration, all kinds of stuff going on. So splitting of lumber near connections should be noted by the inspector as deterioration, recommended for maintenance and upgrade. Again, so here it looks like we have some really small lag screws with some nails and some splitting all the way across in this one. You're just losing your structural integrity of these split boards, and a lot of times, depending on the configuration of it, you might start to see where the top board is tipping out to the left, and the bottom of the board is also tipping out to the left, and so this is crowning here. which is causing, part of the reason why this crack is occurring. So this might be that the joint or this joist specifically is overspanned, and that's why you're getting a little too much deflection, which is causing these cracks, these stress cracks. You see this a lot too in overspan in floor joists inside of a home. All right, guardrails, safety guards. Commercial code 42 inches high, but residential 36 inches. Used to be 30 inches, so you're going to see a lot of safety rails that are 30 inches high, with one horizontal baluster or support, not support, but a barrier, safety barrier along the middle. Anything horizontal we call out for potential hazard for kids. I have a great picture of a kid climbing up a horizontal railing, and with his belly hanging over the top of the rail. That's so. Even if we have guardrails, or even if the balusters or the cables are horizontal, it was intended to be that way. I always say, hey, this was designed, this was intended to be this way. You might like this aesthetically, but you just need to know that a kid can potentially use this to climb and fall over the top of the rail. So you got the 36 inches high, used to be 30 inches. And I think if you're going to do on a VA loan, if you have a house, a homeowner, a buyer that is getting a VA loan, pretty sure the VA requires that even if the railing was 30 inches high, I think the VA requires the railing to be 36 inches. So keep that in mind. Also, the 4-inch gap between the balusters. All of that is to protect anybody, potentially kids, from sticking their arms, their hands, potentially going through the railing and falling. Guardrails. So let's see. Canada technical railing height changes to 42 inches above 6 feet. No, I don't believe that is. I think it's Daryl. I think it's still 36 inches. 42. Well, I'll have to check the new 2021 IRC, but I don't think we're at 42 inches. So Daryl's saying that in Canada it's 42 inches if the deck's above 6 feet from the ground. Interesting. Sounds like Canada's a little more stringent on some of their codes than we are here in the US. Continuous load path. So this is all new. So this is kind of what we were talking about before about notching support posts. So where guards are connected to the interior or exterior side of a deck joist or beam, the joist or beam shall be connected to the adjacent joist to prevent rotation of the joist or the beam. So basically what this is instead of these bolts being allowed to come through the band joist, now the connection has to come through the floor joist. And that is all because what was happening, and I think it talks about it here later, is that when the support post for the railing was connected to the band joist, when these would warp, it would pull the band joist away from the other connections. So this is what it's intended to solve. It's intended to stop that warping from causing any deterioration. ADA says 42. Well, oh yes, on commercial. Right. Yes, on commercial. So we were talking about, they say the IRC says 36, but ADA says 42. Yeah, so ADA would be in conjunction with commercial. Major change of requirement that guard loads should be transferred to the deck framing with a continuous load path to the deck joist. This addresses the age-old problem that arises from connecting the guards only to the ring band. Here's another way to do this, and we do not see this in our area yet. I hope we do. Yeah, going back to the deck railings now. So if they use a 4x4 post, and maybe it talks about it here in a little bit, but if they use a 4x4 post for the rail for the guard, it can no longer be notched because they want the full support of the 4x4 post. You can no longer, in the 2021 IRC, you can no longer notch a 4x4 post for the guardrail. It all has to be the true dimensional lumber with the continuous load path to the joist. Yeah, so using the manufacturer, so these are Simpson strong ties. You know, the Simpson strong tie instructions are going to say this is how it all needs to be connected and secured in order to maintain the continuous load path. The image above depicts a deck guardrails posts properly attached with brackets. Because of leverage, a 200-pound force pushing the deck's guardrail outward causes 1,700-pound force at the upper bolt attaching that post. It is difficult to attach deck guardrail posts in a manner that is strong enough without using deck guardrail post brackets. And again, that's basically, so if this was notched out and somebody, you know, a 200-pound guy, pushes on that post, there's a lot of tension and stress that's going to go there, which can potentially crack that support post, which now, now that post is not going to do its job by protecting the occupants on top of that deck. And everybody knows, when you go to somebody's house with a deck, I do it. I know my friends do it. When you go out, you go and lean on that deck rail, and you're drinking your beverage, and you get a few people doing that all the way down, and you potentially, if this was notched in without the continuous load path connection, all of you that are leaning against that post, that could catastrophically break, and everybody falls off that deck. This is just showing how horizontal wood surfaces on the exterior are no good. You want everything to be angled to shed water away, because and I think everybody sees this probably out in the field, but these being horizontal like this, man, you start to see this wood cracking and separating. And since these are safety guardrails, you're losing that support post. You're losing that structural support there, that safety support as these things weather and age. So angling all the cuts on these are going to help to maintain the structural integrity of these safety mechanisms, and making sure that water sheds away from them is the best practice. All right, we're talking about guardrails, 36-inch minimum, greater than 30 inches from the ground. Yeah, so if you have a slope or any ground connection that's 30 inches off the ground within 30 inches off the ground within 36 inches, you need a guardrail. I think we're all pretty bad. No notch post. So this is what we're talking about. Sorry guys, I got to turn on my. All right. 4x4 guard post can no longer be notched at the connection point. However, a turned 4x4 or one notched within its length may be allowed. So that basically is saying that you can't notch the connection here, but if you wanted to notch somewhere up here to put in, a horizontal support post or rail or something like that, that you're then going to put in vertical balusters, you can do that. Oh, so he's saying, so Daryl's saying the bench would be the start of the measurement, as the bench is a platform. So the bench here is the platform, so that the rail is drawn would not comply. I see what you're saying. So basically the 36 inches would have to start here at the platform and go continue up, not from the floorboard, because this is a walking and standing space. I get you. That makes sense there. I appreciate that. Pedro asks, are you going to address floating decks, those that are not attached to the dwelling foundation? So, so the floating decks, basically everything that is on the outer band joists of the deck now has to comply to the house side of the support structure. When you're if you all the connections that are on the outer bands need to now comply with the house side of the band or house side of the ledger board. Well, it's not going to be a ledger board anymore. It's going to be a band joist. So yeah. So that was for Pedro. Raymond, but the 36-inch high minimum now needs to be but higher. All right, so okay, all right, on to the next. All right, we talked about this already. Turn 4x4, you can notch within the length, but not notched at the connection. The 4-inch sphere, we kind of talked that about. Most residential code requires the top of the guardrail to be at least 36 inches from the deck surface. Most commercial code height is 42 inches and ADA. Yeah, so we kind of already talked about this. Horizontal balusters, not a good idea. And mainly it just comes down to kids. Kids love to climb. That's what they were made to do. And so just don't recommend it anymore, especially with cables. And then cables are so flexible, even if you keep them, the minimum distance recommended, they're flexible in the middle so that a kid can potentially, stick his head through there and then kind of get stuck. I'm not a fan of cables, but they are so popular right now. I imagine it's just a fad. They'll probably go. Guard supported on the top of the deck framing. The NADRA deck evaluation checklist. Short nails not approved. 10D, 1.5 nails may not be used as double shear nails. It's just not enough or not long enough to bite it. There's no way that we'll be able to know that unless unless some are laying around or one is backed out or something like that. But definitely want to make sure that you have the full length of the nail approved. Ramps longer than 6 feet should also have handrails on both sides. This is something that we're still getting used to around here, having graspable handrails. People still like to use just the top rail. The 2x4 turned on its side as a top rail. It's not adequate as a handrail. Just doesn't provide. You don't need handrail whenever everything's going right. You need a handrail when you have a problem. When if you trip, you need to be able to grasp onto something really, really quick, really fast. You can't do that with a 2x4 on the side. If you're tripping going up, tripping going down, you need something to be able to grasp real quick. So that's the primary reason to have a graspable handrail. And then they need to be 34 to 38 inches up from the tread of the stair, all the way up. It's not often that we see handrails that are too low anymore. 10 minutes out. Oh, let's see. Let me look real quick. How many? Look and see where we're at. Okay, we're pretty close here. Oh my gosh. Let's see. Try and bust through this. Okay. All right. And then the balusters of a stair rail, 4 3/4 inch sphere, and then on the tread, a 6-inch sphere. So, do those measurements to see. 5 feet maximum between posts. Maximum allowed gap for 4 3/8 posts gaps. 4 1/4 okay here. Okay. 4 3/8 sphere. Maybe that's might be 4 3/8 for the balusters on the stairs. But and obviously I think this is all going to be, your local code can make all those changes, and code's different. You have state code sometimes, you have local code, and then you have a mixture of both. So a lot of this stuff will change depending on where you're at. 21 IRC code changes. Guardrail must resist 200 pounds of concentrated load only in the outward and downward direction. The old rule was resistance in all directions. Yeah, not sure how much of that. I think that might actually lax some of the rule because, but on hindsight, I think the changes to the guardrail, especially notching the 4x4 posts, is going to increase the code requirement. So I'm not sure what would have changed from the old rule in all directions, but other guard materials, and people can come up with all kinds of stuff to make decks and guardrails out of. So just got to make sure that you don't want any movement in your guardrails. You want to make sure the distances in guardrails are correct. You want to make sure there's no rot, deterioration, and hopefully everything is designed, manufactured to be a guardrail. But there's all different kinds of methods and materials out there that you use. Just use your best judgment and make sure that it's all safe. That's the primary function. It's safe. When we're talking about guardrails, it's primarily safety. So you just do your due diligence, make sure that the methods and the materials that we use are safe. Are safe. Balconies, decks, and porches. Outlet. Outlet must have GFCI protection. Should have an all-weather cover. It's pretty standard for exterior outlets, but you do need an outlet on a deck. That's to for repairs. You're not going to be running outlet extension cords all through everything that can cause issues. It's kind of like having an outlet or a power source near an appliance. Near a major appliance like an HVAC system, that type of stuff. This is the same concept. You don't want to have to run power cords and be out of view when you have power, when you have a cord and you're trying to do repairs and be safe. Balconies, decks, and porches that are attached to the dwelling unit and are accessible from inside the dwelling unit shall have at least one receptacle outlet accessible from the balcony, deck, or porch. The receptacle outlet shall not be more than 6.5 feet above the balcony, deck, or porch walls. So this means that, maybe, and I guess it all depends on how the house is constructed, but you can't really use a soffit outlet as the outlet for the deck out. But again, it's going to vary depending on how things are built. Deck cannot inhibit access to things like a septic tank. 3 minutes. Things like a septic tank restrict access from an egress. So that's standard fire safety. And then septic tank, man, I've seen a lot of decks built over septic tanks and pools or old pools. I mean, just wild stuff. But I've seen more septic tanks or decks built over septic tanks than I have any other material or any issues with egress on houses. But it's not uncommon. All right, inspecting. Start by looking on the underside of the deck. Make sure everything's safe. Make sure everything's probing. Push on columns, posts. Make sure there's no sway or movement. Look for rot as you go across the deck. Make sure you're looking for flashing. One of the primary things to look for. Push on the handrails, the guardrails. Check baluster widths and other openings. And are you comfortable on this deck? you are on more decks than probably anybody. So make sure if you're uncomfortable in any way, you need to identify what's causing that feeling and call it out. Evidence on non-compliant work and modifications completed without required permits or inspections. Evaluation and compliant repair by a qualified contractor is recommended. Not constructed to best practices is common, sometimes subjective, is an indication that work was not compliant with the standards at the time done. All right. Oh. And unless otherwise noted, decks not built to best practices or local standards may be usable at the time of inspection, but remedial work is recommended by a qualified contractor to ensure that deck continues to be safely serviceable. All right, guys, I think we got 1 minute. I really appreciate everyone being here. And if you have any questions, concerns, recommendations, I am all about constructive criticism. I would love any feedback you have. Please email me at admin@tradexuniversity.org. And I really appreciate y'all. Have a great day. Have a great night.